Hello everyone, welcome back to the channel. Today, in Windows System Monitoring Practical Series, we will monitor system memory utilization and understand how Windows manages RAM resources. We will analyze memory allocation, cache memory, committed memory, paging behavior, and real time memory usage. So let's start right now. Now we are monitoring system memory utilization. Memory, also known as RAM, stores actively used applications and data for fast access by the processor. Efficient memory management is extremely important for overall system responsiveness and multitasking performance. This graph displays real time memory usage over the last 60 seconds. It helps administrator observe memory consumption trends and identify sudden increases caused by application or background processes. In this case, memory utilization is relatively stable with moderate system usage. At the top right corner, we can observe the total installed physical memory available in the system. This system currently contains 16 gigabytes of RAM. Physical memory directly impacts multitasking capabilities and application performance. Systems running virtual machines, browsers, security tools, or large applications typically require higher memory capacity. The in-use value represents memory currently being consumed by the operating system running applications and background services. In this case, approximately 9.2 gigabytes of RAM is actively being utilized. The available memory represents memory currently ready for immediate allocation to application or processes. In this case, approximately 6 gigabytes of memory remain available. If available memory becomes critically low, the operating systems may start relying more heavily on virtual memory stored on disk. Cache memory contain recently accessed data temporarily stored for faster future access. Windows intelligently uses unused RAM as cache memory to improve system performance and responsiveness. Cache memory is not wasted memory because Windows can quickly reallocate it when applications require additional RAM. Committed memory value represent total virtual memory reserved by application and the operating system. This includes both physical RAM and paging file allocation. If memory demand exceeds physical RAM capacity, Windows may utilize the paging file stored on disk. Page pooled and non-page pool. The page pool contain kernel memory that may be temporarily moved to disk when not actively required. The non-page pool contain critical kernel memory that must always remain inside physical RAM. Administrators often monitor these values during advanced troubleshooting of drivers, kernels, memory leaks, or system instability. The speed value represents memory transfer rate. Higher memory speed may improve data access performance and overall system responsiveness. This indicates that both available memory slots are currently populated. Hardware reserved memory is allocated for hardware level operations such as integrated graphics and firmware functions. This portion of RAM is unavailable for normal application usage. Memory composition bar provide a visual representation of how RAM is currently allocated across active usage and available memory regions. This helps administrators quickly evaluate overall memory pressure. When available memory becomes too low, Windows may increasingly rely on virtual memory, which is significantly slower than physical RAM. This can lead to reduced system responsiveness and application slowdown. In an enterprise cybersecurity environment, SIEM tools, endpoint protection platforms, and virtual machines may consume sustainable memory resources. Overall, memory monitoring helps administrators identify RAM bottlenecks, excessive resource consumption, and potential performance degradation. As more applications are opened, memory usage increases in real time. This helps administrators determine whether a system requires memory optimization or hardware upgrades. In this part, we analyzed system memory utilization and understood how Windows manages RAM resources. We also generated additional memory usage to observe real time changes in memory consumption. In the next part, we will monitor disk activity and analyze storage performance. Thank you for watching. See you in the next video.